Hello, I'm back again, and today I'm going to be talking about a data science project that I'm doing, and this will probably be one of the first of many data science projects I will be talking about here. So, this data science project was one of the ones that I did on aerospace data, and this project was actually exhibitioned at the South Carolina CTE Showcase this year. So, without further ado, let's get started and take a look at what this analyzes and what we can learn from this project. Alright, so this project is called our METAR analysis. And what this is we're basically looking at these codes that are provided by the government. But actually, they're provided by the FAA, which is quite nice. And these codes are called METAR codes. And what they do is they're these little long broad lines of letters and numbers that give you information about the weather at a certain airport. And these codes are very important because airplanes, when you fly them, they fly in the sky, right? And they're usually held up by things, but they're usually impacted by things like the cloud coverage, the wind, rain, stuff like that. So looking at the weather beforehand is very important, and it could obviously make the difference between a very successful flight and a bad crash. And when you actually look at a lot of these crashes in general aviation, most of them are due to lack of attention to weather. So we're just gonna go through and we're gonna look at how this METAR code works, how to understand it, and then we'll just look at ways that we can analyze these codes and basically make conclusions off of them. So let's start by looking at the METAR code and what it means. So the first code right here is the METAR tag, and that basically will tell you whether the rest of this is based off of the instrument or if it's based off of observations. And if it's off of observations instead of METAR, it'll show SCCTE. The next word right here is, or the next, string of letters is the ICAO code, or so some people call it the identifier code. And it basically just tells you what the name of the airport is in a short burst of information. The next code, this third one right here, is the time. I think it's in Unix format, I'm not sure, but it's in a special form that is easy to read by computers. Whoops. Okay. The fifth, and the sixth values are wind information. Seventh shows visibility in meters. So at this airport, it would be 5,000 meters. The eighth value shows you the weather condition, and there's a bunch of different words for weather condition. Then the 9th, 10th, 11th show cloud condition, and the 12th shows the temperature, and then so on and so forth. So what we first did was we imported our stuff as per usual, prerequisites, and then afterwards we opened up our data. And our data is from two airports. One of them is from KGMU, or the Greenville Municipal Airport, and the other one is from KCHS, or the Charleston International Airport. So when you look at the structure of these files, you'll see right now there are 39 different columns, and they have basically what's in this METAR code broken down into a comma separated values file, and it's all nice and organized. You see we have the METAR ID, temperature, dew point, wind speed, wind direction, gusts, visibility, and also stuff that you normally wouldn't get, like the receipt time, because it's putting them out in codes that you'd get on a computer. And then here again, this is in a more user readable format right here, where you can sort of see better what you're looking at, and there's a lot of them. So yeah, and then that's basically what we first did to open up and see what we're actually looking at. So we'll go to our first test, which is the time versus temperature test. And here we are looking at temperature patterns between the two airports of Greenville and Charleston. And for the we are looking at them from the times of the 25th of November to the 29th of November because that's actually when I first started working on this all the way back in November. And we're just sort of looking at how it goes, right? So here in the Greenville Municipal Airport, you'll see the temperature over time. When it is 00, it's usually the middle of the night, and when it's 12, it's noon. So when you actually look here, usually it'll reach the peak troughs, or the like deepest section of these troughs, are usually early in the morning or at night, and that makes sense because at night, sun's gone, it's cold outside, and then it'll peak later in the afternoon, which the sun's been out for a while, everything's had time to warm up. But what's important here is when you look at the peak of this graph on the 28th of November in the afternoon, or on the 27th of November in the afternoon, it peaks at around 14 Celsius. And this is important because when you go down to this graph right here, which is, once again, the time versus the temperature at Charleston's airport, you'll see that the graph tends to peak at around 17 Celsius, which is interesting. Here 14, here 17, right? And this shows that, right, in Charleston, the weather is warmer than in Greenville. And if you think about it, that makes sense, right? Because Charleston is further down south, closer to the ocean, closer to the equator, which means you're going to get a warmer climate. And Greenville is further up north, further away from the equator, I think also at a higher elevation, which, once again, changes how the temperatures will look. And that's basically a very basic test that we did just to make sure that these values that we get from our files were working. So next, we're looking at cloud coverage of these two airports, right? And how I did these was I looked at the different types of codes, and I looked at how many they were. So I kind of looked at the diversity of reports at the airport. And here's what I noticed. When we look at Greenville's airport, right, KGMU, you'll notice that there's well above 60 reports of clear skies. And there's a couple, 30, of overcast, but that was just because during the time that I took this, we were having some bad rain a couple of times, but it wasn't too often. And then here in KCHS, or in Charleston, you'll notice that majority of them are few clouds, broken clouds, or scattered clouds rather than clear reports. And this is interesting, right? When we look at the results, that shows that there just tends to be more clouds in Charleston than in Greenville. But we can sort of take that up to the next level and assume that the reason why it's like this is because there would be more volatile weather off the coast, and it's also cloudier. And if you've ever been to the ocean, you'll know that there's lots of wind pushing inwards from the ocean during the daytime. And we think that's why it's cloudy. Clouds will come out of the ocean from the water evaporating, and then it'll get pushed inwards by the wind. And that's sort of where all these reports of few clouds, broken clouds, scattered clouds come from. And this is important, right? Because when you take off with an airplane, a lot of the times it's actually illegal to fly through clouds unless you have a type of pilot's license that's actually higher than the normal pilot's license that you'd get, called an IFR license, which is like instruments, because since you can't see in the clouds, you need to read your instruments rather than just looking at your environment. And that is important because, if you don't have that and you can only fly based off of what you see around you visually, then, you can't really take off. So that's very important, once again, looking at this weather data. And our last column is cloud coverage versus visibility. So since we know that Charleston, there's lots of clouds, we basically look at these reports over time and look at the visibility over time. And what we'll notice is whenever the cloud coverage is at overcast, the visibility here tends to be around 6,000 meters, and that's interesting, right? Because the visibility is very important when you're flying airplanes, right? Once again, it determines whether you can fly with normally or if you need that extra certification to fly through the clouds. Because if it goes lower than 7,000 meters, I believe, then you have to fly with that instrument permissions. And this is once again is important because if you're not able to see this and you already get up into the air and realize, oh crap, I can't see anything, then you're gonna have some problems. So that is very interesting. And those are the three main analyses that I ran, and they're very interesting because it shows how weather can have huge impacts on what happens when you fly an airplane. So yeah, that is the project. So as you can see, we've learned a lot about clouds and airports, and this sort of studies are interesting because they show how the things like weather and temperature will interact with how planes can take off and land. And it's very useful to sort of see these things and visualize them so that you can understand it when you're doing stuff like flying airplanes or just moving throughout the world in general. Yeah, I've learned a lot through this. It was pretty interesting, and data, pretty cool. That's about it. Adios.